All right, we are continuing on talking about some characteristics of graphs. Some of these we have discussed before. Some of them are going to be a little bit new. So the first thing we're going to talk about is increasing and decreasing. So the way you can determine this is if you imagine a little person is walking on your graph from left to right, are they walking uphill or downhill? And you mark this by the x values, and we use interval notation. So where my graph starts here at 0 until about 2, I am walking uphill. Now, I'm going to use a parentheses at 0 because I don't know what's going on prior to that. And then at 2, I'm changing direction. So I'm neither increasing or decreasing, so I am going to use a parentheses. Okay. Then here at about 6, until infinity, because of that arrow, I am increasing, walking uphill again. So I'm going to put a union between those two intervals because they're both part of my answer. And so as far as where I'm walking downhill, well, that's from 2 to 6. And again, at both of those points, you're changing direction, so they get a parentheses. Okay, what about positive and negative? This is when is your graph above the x-axis and when is it below the x-axis. And you're going to use your x values to indicate this. So let's start with where it is negative. When is it below the x-axis? Well, that's here from -4 to 0. Now, at both of those points, my graph is 0. 0 is neither positive or negative, so it's going to be marked as parentheses at that boundary. Okay, now where is my graph positive? Well, everywhere else. So from -infinity to -4, I'm above the x-axis. And then again from 0 to positive infinity. And I'm going to put a union between those because they're both part of my answer. Okay, one more characteristic, we're going to talk about end behavior. So this talks about when I have those arrows going off to infinity, what is my graph doing? So here I have two arrows, so one of my end behaviors is going to be as x goes to positive infinity, and the other one is going to be as x goes to negative infinity. When that is happening, what is y doing? What is my function doing? So here, when x goes to positive infinity, my y is going off to negative infinity. And on the left side, when x is going to negative infinity, y is going to positive infinity. Okay. Now, it's not always going to be infinities. For example, here, this is an exponential function. So I still have two arrows, so I'm going to have two end behaviors where x is going to positive and negative infinity. But y here, as I go to positive in the x direction, y is getting bigger and bigger positively, so that's positive infinity. But on the left side, when x is going to negative infinity, my graph is getting really, really close to the x-axis without ever crossing it. So my y values are actually getting really close to 0. Now, with all of that in mind, let's apply that to some other graphs. Where is this graph increasing? Well, I've got an arrow that tells me that this is from negative infinity until about 0, I am increasing. Then again, here about 5 until positive infinity, I am increasing again. Which means I'm decreasing on those other in-between parts from 0 to 5. My graph is positive everywhere here, so that's from -8 until 3. And then again from 7 to positive infinity. And then I'm negative here from negative infinity to -8. And then again from 3 to 7. Now, end behavior. As x is going off to positive infinity, my y is also going to positive infinity. And as x is going to negative infinity, my y is going to negative infinity as well. Another little graph. Where is this one increasing? Well, from 0 to 1, I'm walking uphill. Then I'm kind of stagnant. And then I start going uphill again at 2 until positive infinity. I'm decreasing from negative infinity to 0. My graph is positive everywhere except where it touches my x-axis, because remember 0 is neither positive or negative. So I have to exclude that. It's never negative. It doesn't ever dip down below the x-axis. And then my end behavior. As x is going to positive infinity, so is y. And as x is going to negative infinity, y is also going to positive infinity. Okay, this next one is going to be a little conceptual because I don't have a graph, so we're going to have to visualize this. I've got a graph with these characteristics. I'm increasing from negative infinity to 2, and then I'm decreasing. I'm positive from 0 to 5, negative everywhere else, and these are my end behaviors. And we're actually going to change this one to be negative infinity as well. Both of my end arrows are going downward. Now, if I transform this function in these various ways, what is that going to do to each of these characteristics? So let's start here. Well, first of all, what is happening? This is a reflection over the y-axis. So your graph flips over the y-axis. This changes your x values. So things that are describing your x values are going to switch from positive and negative. So this means instead of increasing from negative infinity to positive 2, you're going to be increasing from negative infinity to negative 2, and then decreasing from negative 2 to positive infinity. Your positive is also going to switch. Instead of being from 0 to 5, it's going to be from negative 5 to 0. And your negatives are also going to switch. So this is going to be from negative infinity to negative 5, and then again at negative 5 to infinity. Or sorry, not negative 5 to infinity. This would be 0, not negative 5. Okay. And then my end behavior did not change because my graph, the only thing that's going to change that end behavior is if I flip upside down, and I did not. So my end behavior is going to stay the same. Okay, on 22. This time I am reflecting over the x-axis. I am essentially flipping upside down. This is going to change my y values. So my intervals of increase and decrease are actually going to change because I am now going to be decreasing at the start and then increasing the rest of the way because I flipped upside down. My positive and negatives will not change, are going to change as well because again I flipped upside down, so these are actually just going to switch. So I'm now negative where I was positive previously, and then I'm negative where I was positive, and my end behavior is also going to flip-flop. So both of these end behaviors will now be positive infinity because I flipped upside down. Okay, on to 23. I am going down 3, just shifting my graph down 3. So my intervals of increase and decrease will not change. My end behavior will not change either. Now, my positive and negative intervals, this is one I'm not going to be able to answer if I don't have the physical graph. It's going to depend how steep your graph is at that point where it's becoming positive. So if you think about it this way, here's like a rough sketch. My graph is doing something kind of like this. Okay, I'm starting off negative, I go to the positive, and then I go back to the negative. If I shift down 3, depending on how steep this mountain is, it might stay in the positive. Or depending on how flat it is, it might all go down into negative. I can't answer this without more information. And then the last thing I'm going to look at is if I'm shifting to the left one. So this is going to change all of my x boundaries decreasing by 1. So I'm going to be increasing from negative infinity to 1 and then decreasing from 1 to infinity. My positive interval is now going to be from negative 1 to 4. And my negative interval will now be from negative infinity to negative 1. And then from 4 to positive infinity, and my end behavior does not change. And that concludes our notes on characteristics of graphs.